A very good morning to one and all. Today we are going to discuss about a new topic in the distributed computing system, that is the challenges of designing a distributed systems or the distributed applications or simply the distributed environment. Let me move on to the slide. So to summarize what exactly we are going to discuss on this topic under the challenges is, whenever if the user they want to develop any application or they want to utilize the distributed environment. As the distributed environment, there are so many components are there. Wide variety of different components are located geographically. Whenever if we want to accomplish any task by using the distributed environment, obviously we have to go with the message passing concept. Obviously we have to go with the message passing schemes. So the communication interfaces plays a role here for achieving whatever the stipulated task or achieving their goals of the individual users. Now, when we say that a distributed system is a collection of components, obviously that are in heterogeneous in nature. Every component is having its own methodology of handling of the messages. Say for an example, the message passing scheme is different from the Unix or a Linux flavor to the Windows operating system. The computer hardwares are in heterogeneous in nature. The vendors are in heterogeneous in nature. Now, but we want to hide all these heterogeneous devices, and ultimately it allows the system or allow the users to accomplish or to achieve their own task. So the heterogeneity is one of the main challenges when we want to design. If any distributed system developer, if they want to design anything, they have to keep in mind of the heterogeneity, the first point. And second thing, as based on the definition, we said there are so many components are connected. There are so many components are there, computing components are there, that are located in the entire geographical locations, that are connected through the networks. Obviously, the communications will take place from one component to the another component, that is only by using the message passing scheme. If I am using this, obviously there is another one big challenge is coming to our mind, that is called as security. Whether the authenticated users are accessing the components or utilizing the resources. And one of the primary motto of the distributed systems are the resources are shared. Now every user, they are willing to access the resources. So we have to provide the sophisticated secure environment to authorize and to identify the various users to access the resources. And also, we have to enrich the confidentiality of whatever the data which I am going to transmit or pass from one system onto the another system. That is another one biggest challenge here. Because in the recent days, that well-known attacks are, since we are living on the era of data, every data is having a huge value. right? So in this context, the cyber security attacks is also increased like anything. Still the open case, that is called as the denial of service attack, DOS attack, right? This is another one challenge. And when we are thinking on the distributed applications, obviously we have to immediately stuck into our mind that the concurrency. So there are more than one users, they are trying to access the same resources on the concurrent manner. They are trying to accomplish their task on the concurrent manner. The system supposed to provide this to make to create the illustration to the each and every user that the resources are maintained on the consistent way. It is in the consistent state. Right. So that is also one of the biggest challenge to maintain the concurrency. And next is, when you are thinking on what are the challenges we are supposed to face while developing the distributed system, that immediately it comes in your mind the next thing that is called as the scalability, scalable in nature. I can add, I can remove, or I can replace any component whenever I need or wherever I need. Right? And next foremost thing, that is also one of the ultimate responsibilities of the distributed system. The reason we are moving on to the distributed system is because of it having its fault tolerance. The computer hardware may fail in sometimes, or fail to coordinate in sometimes, or fail to achieve some task. So we have to handle those failures also. That is called as a fault tolerance, or the failures. There are the ways, particularly in this, there are the ways to overcome the failures. The main thing is, if there is any failure in the hardware component, it means that only that particular component it doesn't capable to perform the assigned task. So what we can do it? We can use the redundancy concept here. We can add more number of the same resources whenever we feel if the component, if the resources is failed to perform the operation. Or otherwise, just simply ignore the message, ignore the failures by dropping a message, the system is failed, and continue to work. Now for this, how I can, if you have a question like how I can ignore the messages by simply dropping a message, ignore the failures by simply dropping the messages. Now whenever you are accessing the internet through the web browser, if the web browser is not connected, if there is any failure, then automatically what it will have do is, the web browser it displays some errors, 404 errors or a 401 error, some errors it will give us some alert messages which will be generated to us. Then automatically what we are going to do, it means that okay, leave as it is to the customer and then not a customer, user and then resources, like they will try after some time. This is the other way to handle the failure. And next is adding more resources, the redundant resources, that's the one way. And simply ignore the messages. Right? Because on the distributed environment, if there is any failure on the remote server, it is very tedious to detect. It is very tedious to detect. So we have to define a proper handle the proper strategy whenever if there is any components are failed. That is also one of the important design challenges. And transparency. Right? When you are saying all these things, when you are discussing all these things, immediately that comes in our mind that since I want to provide a higher quality of the services, whatever the applications, whatever the idea of the users, we want to have a higher quality of services. So the quality of service is also having one of the biggest challenges. While designing the distributed system, these challenges we have to keep in mind for the proper distributed system. Right? So let me go to the slide in detail to know about what are the challenges and how it's supposed to be overcome, all those things. So these all are the variety of challenges which some of them are already I said. I hope in this the only one thing which I left is called as openness. The only one thing which is called as openness. So these are all the various challenges while designing in distributed applications. So the architect or the designer of the distributed systems, they have to keep in mind of all these things while developing any application. Whatever may be the architecture, these are the typical challenges. Let me go in detail what is called as a heterogeneity. Heterogeneity, as I said earlier, heterogeneity it means that there are the wide varieties of the components are associated on the distributed systems. The computer hardware is vary, the computer softwares are vary, and the vendors are vary. But what we want to do, this distributed computing system, it hides all the heterogeneity and to bring the entire things into the universal format or the internal format to achieve their own task. They achieve their own task. So that is called as a heterogeneity. So it is a heterogeneous collection of computers and the networks. Whenever if we are trying to access or utilize any services by running of applications, that can be done only with the help of the heterogeneous computers on the internet. Alright, so what are the components are heterogeneous in nature? All the computer networks, a computer hardware, the operating system, a programming languages, implementation, that is vendors, that all in different in nature. Right? Let me take only two here. So the operating system, how it is different. Now, to achieve this, especially to achieve this, what I want to do, I want to use the message passing schemes. The communication is to be established by using the interfaces. Now, the handling of the message passing schemes are vary on the Windows operating system and the Unix. Likewise, every individual users, they are writing their programs by their own languages. Whichever the languages, the programming languages they are comfortable, they are written the program, they developed the application. So here what we want to do is, here we want to provide the standardization that's supposed to be standardized. That is, the meaning of the standardized is it is not possible to provide the unique format to all the programming languages, the same syntax to all the programming languages. In one programming language, the integer value it takes only the whole part. In some programming languages, it also takes the floating point values also. So these are the heterogeneities are there in the programming languages. So what we want to do, we want to standardize, we need to have a standard concept, standard mechanism to make everything onto the proper internal format, a common internal format that can be done with the help of a new component that is called as a middleware. One of the example of this middleware is called as a Corba. Right? And next is, if we take another one example, how the networks are heterogeneous. Obviously, what is my aim? I want to accomplish a task, so I am utilizing the internet. So from my system, the internet is connected only through the interfaces that is called as the Ethernet cable, Ethernet. Then every computers on the Ethernet on the internet era or the internet site, it should enable the internet protocol option, it should enable the internet applications, internet protocol applications, so that the communications will be the communications is established. We can exchange the messages, we can perform whatever the operations. Right? So these are the some ways the collection of computers and networks are in heterogeneous in nature. Right? So all these things, all the differences we are supposed to mask when we are trying to perform any operations or when we are trying to achieve any operations. So their differences are marked by the way that all of the computers attached to them that uses the internal protocol to communicate with one another. The example here is, as I said, the Ethernet. The Ethernet is supposed to be implemented with the internal protocol. Then whatever may be the vendor of the Ethernet, that we can bring brought into the simple standards. Everything will work on the concept of an internal protocol. Because whatever the type of the Ethernet, that is implemented with the internal protocol. Right? I think you understood what I am trying to say here. Right? And I am coming to the programming part. So the data types such as integers may be represented on the different ways on the different hardware. The well-known example, the representation of a data can be defined in the two way. One is in a big Indian architecture and then little Indian architecture. But my aim, since I am the end user, I am the user of this distributed system, whether I don't bother about whether it is based on the big Indian architecture or little Indian architecture, but ultimately my application is supposed to be run and I need to get the result. That's all. So we have to mask or hide this heterogeneity to bring the entire thing into the uniform interfaces, or to bring the uniform internal formats. Right? This is also another one example. And message passing schemes on the operating system side, that is also vary. Right. So whenever if the user is approaching any devices or any components, that can be done only with the help of application programming interfaces, APIs. And these APIs and need not necessarily the same application interfaces. It depends upon their own what is the type of programming languages they are using. So the application interfaces, the user interfaces are vary. Right? For example, the exchanging of messages in Unix are different from the Windows, and they have a different programming languages. It uses a different representation of the characters and as well as also the data structures. Right? So these differences are essentially to be addressed for the smooth completion of the distributed application. Or whenever we say my environment is a very convenient and easy environment to run any distributed system applications, then we have to clear all these differences. We have to hide all these differences. We have to mask all these differences. By the way, any applications written in one programming languages are essentially to be communicated to other programming language. Or other way we can put it in, since the object oriented is very popular, the object in a one entity and in one component is essentially to perform the communication to the another object, and it access the another component, access the another object, then it has to complete the respective works. It has to complete the respective works. Right. So in this context, what we want to do? So obviously we need a common platform. We need a common standard. Unless otherwise, this heterogeneity cannot be masked or cannot be hide. Right. So what we want to do is to standardize this. I'm using some strategy or some rules, not on the universal rules, because when I'm moving on to the universal rules, obviously it takes much more time. Right? So what I'm trying to do, I'm trying to use a component that is called as a middleware. The middleware which are applied to a software layer. Now this it provides a programming abstraction, that is masking the heterogeneity of the underlying networks, not only for the network, all the components, all the essential components which are resided on the distributed environment. So this middleware is capable to provide the abstraction on the programming and operating system and hardware devices, the various hardware devices. So the the well-known example of the middleware is Common Object Request Broker, CORBA. CORBA is one of the well-known example of the middleware. Right? And some of the other middleware which are dependent on the certain programming languages. Say for example Java, Remote Method Invocation, RMI. But this is typically based on the Java. Right? So it is based on this interface, this common standard, this middleware, which is based on a single programming language. So obviously what it means, if the users are using the remote method invocation, especially the Java remote method invocation, and both the users are adopting the Java programming, but whereas the CORBA is common. Right? And most of the middlewares are implemented over the internet protocol. Because as a distributed systems perspective or the distributed computing perspective, every users are accessing the various components through the internet. They are achieving their tasks by accessing the various components or various resources through the internet. So obviously these middlewares are supposed to be implemented over the internet protocol to mask the differences. To mask the differences in the hardware, in the operating system and in the programming languages. Right? And we have to keep in mind this middleware, it provides a uniform computational method. That's why we are bringing that into the common standard. Right? So when you have to keep in mind of a heterogeneity, immediately the middleware plays a role to hide all the heterogeneity problems or to overcome all the heterogeneity problems. But this middleware, whichever the middleware we are going to choose, that it provides a uniform computational method or the model to succeed their application or to achieve their goal. Right? The possible models are remote object invocation, remote event notification, remote SQL access, and distributed transaction processing. These all are some of the computational methods where the middleware can work based on this. Right? For example, the CORBA, which is based on the remote object invocation, what it is exactly going to do is, so the CORBA which allows the objects which are running in the one programming on the one computer to invoke or to access the other objects which are residing on the another programming language or other programming language on the another computer. So its implementation, it hides completely the fact that the messages are passed over the network in order to send the invocation request and its reply. Because if there is no CORBA, if there is no middleware here, obviously the way of sending the request and receiving the response of the one object is completely different from the another object, because every object is written in the different programming languages, handled in different programming languages under different systems. Right? So the next is under the heterogeneous, we want to concentrate on the heterogeneity under mobile code. So what is called as heterogeneity? Heterogeneity we seen. So the various components are resided. Now what is called as a mobile code? The mobile codes are the program codes. Usually we referring that mobile codes are called as a program codes, which are transferred from one computer to another computer. Even if we are transferring, it is allowed to execute. It continues execution. Whichever the machine which we are transferring, it is transferred to, that machine is also capable to execute the mobile code. The one familiar examples of the mobile codes are called as the Java applet. Now in recent days, we can say the JavaScript. That is also one of the well-known example of mobile code on the today's environment. Right? What it will do? So only it allows. That's why we are going to say that the Java is called as a Java Virtual Machine, JVM. Java is a JVM, Java Virtual Machine. It allowed to execute to any of the system by only transferring the messages. Right? So the executable programs are normally specific both to the instruction set and the host operating system. So here the virtual machine is facilitate the way how to execute these instructions, to handle these instructions. So whenever if I am trying to execute these Java applets which are transferred from one machine to the other machine, whenever if I am trying to execute, it invokes the virtual machine instruction set and it continue to execute. So for example, the Java compiler produces the code for a Java virtual machine. It executes it by interpretation. So the JVM needs to be implemented one for each type of computer to enable Java programs to run. So the most commonly used mobile codes and recent days the inclusion of a JavaScript program. Right? So this is the way we can handle the heterogeneity. Next is called as the openness. So the next challenge is called as the openness. The openness, it defines or it determines whether the system is allowed to re-implement or it can be extended. If I want to add any resources, is it possible to extend? Or we can re-implement the entire system by using various ways. Now this can be determined based on the resource sharing and how these resource sharing services are available to the client. So depends upon these two factors. We can think of whether we can extend or whether we can re-implement. Right. So this cannot be achieved without having the key component that is called as a software interfaces. Right. So what we want to do this to have the openness on the distributed system. Now all these key software interfaces are made available online. That has to be published. Let's say for an example. Now we are running the wide variety of internet applications. Right? So every internet application, if I want to know the thing is every internet application is documented. Right? So the document name we can say that is called as RFC, request for comment. Every document, if I want to check with the working principles of the SMTP, we have a RFC document. This document is a standardized document. By the working groups of IETF, Internet Engineering Task Force. Likewise, every software key interfaces are to be standardized by making available to the software developers by the way of the key interfaces are published. The key interfaces are bubblies. So this process is similar to the standardization of the interfaces. For this, now here I am bypassing the official standardization procedure, which are usually the slow moving. Right? So the challenge is to handle the complexity of the distributed system, because there are so many components that resided which are engineered by the different people, which are engineered by the different designers or different developers. So that brings the complexity here. So whenever if we are trying to re-implement or extend, we have to handle this complexity. In terms simply, these all are heterogeneous complexity. Right? So as I told about the RFC, request for comment. Right. So the systems are designed to support the resource sharing. Right? That's supposed to be extensible. These resources are extended at the hardware level and at the software level also. By the hardware level is by adding more components, and for the software level adding more new services. Right? The re-implementation, the extension is also be done by the way of the re-implementation of old ones and replacing with the new applications that continues to be share the resources. Right? So open systems are categorized by the fact that their key interfaces are bubblies. Then only we can able to achieve this. And next, it provides the provision. It used to give the provision of a uniform communication mechanism and bubblies interfaces to access the various shared resources. These open distributed systems are constructed from the heterogeneous hardware and then software. Right? Next is called as the security. This plays the important role. As I talked about more on the security test, I will rush up the points. Main thing when you are talking about the security on the internet era, on the internet, there are the essentially three major components we have to keep in mind. That is called as CIA triad. As being the computer science students, you should know this, what is called as a CIA triad. Now your cyber security systems which are based on the CIA triad. C for confidentiality, I for integrity, and A for availability. Confidentiality has to be provided not only for the messages and as well as also the users or the hardware components, or the right users are using the system, or the right users are using the system. Right? And the resources are available at all the times. This by the way of by overcoming distributed services of attack. The two biggest challenges will come into place when you are talking about the security. Right. So to have this, we have a firewall. So what this firewall will do, this firewall is act as a barrier of whenever if there is any traffic is entering and leaving from the firewall, this is act as a barrier. This acts as a barrier. But on this distributed application, this restricting of the traffic that can enter onto the firewall and leave to the firewall, entering from the firewall or leave to the firewall, it doesn't ensure the appropriate use of the resources by the users within an intranet and as well as also within the internet. Means that these are not protected by firewall. Right. Then what I want to do? In the distributed environment. Now obviously on a distributed system, the client sends a request to access the various resources. Right? It involves sending the information and as well as also accessing the various hardware. Right? So for example, a doctor might request access to hospital for the patient's data or send additions to that data. They can add or they can request the patient data. Then we have to authorize a doctor is authenticated user here. And the next example, in electronic commerce and banking systems, users are very often using their credit card for buying their product, their card details, using their card details for buying any product across the internet. So in this case, the bank or the merchant supposed to be authorized. So what it means, what I am trying to convey here is, if we are thinking on the security, we should not concentrate only on the transmitting of the messages. We have to think on the other aspects also. We have to provide the complete secure environment. Yes, the confidentiality we can done very easily. That can be done with the help of certain security algorithms. That can be done with the help of the security algorithm. We have a wide variety of security algorithms are there. So as I said, there are the two main challenges are playing a vital role here. The first challenge, since I am sending some sensitive information as a message in a message through the internet. The patient data is very, very essential, more sensitive data, and my credit card information, my debit card information, my banking information are more sensitive data. Right? So here, the security is not only for concealing the contents of the messages, not only for encrypting the messages, it also involves knowing the identity of the user. So both authentication and the confidentiality is very much important. Right. The second challenge is we need to identify the remote user. We need to identify the remote users. Right. So these challenges are accomplished by the way of having or using of certain encryption algorithms or the encryption techniques. Right. But the two important security challenges, still it is an open challenge only. One is a denial of service attack. And second one, security of mobile code. Right? So, what is called as this denial of service attack? The third party is not allowing the intended users to utilize the resources by the way of sending the fake request. By the way of sending fake request. Spamming. The more requests has to be sent from this only system. By the way, the bandwidth is supposed to be reduced. Right? And next is the security of mobile code. The mobile codes need to be handled with care. Why? What is the reason? Unknowingly, if we are clicking, this is comes under like I say any executable files, executable program. Unknowingly, if we are clicking no, so automatically what will happen? It leads some other consequences. Maybe it invokes the various resources which are resided on the system, and it collects the details and which are propagated to the third party. At one point of time, this also leads to the denial of service attack. So that's why it is supposed to be handled with care. Right. The fourth design challenge that is called as scalability. The distributed systems are scalable in nature. It's supposed to be scaled in all the levels. That's why the beginning class I said we should not have any vertical scaling. It's supposed to be horizontal scaling. Any growth of the organization, if the organization is having the vertical scaling, it doesn't mean that the organization is growing. This is a sign of the organization. The sign of the organization is only predicted with the help of the horizontal scaling. Only with the help of the horizontal scaling. Right? So ranging from the small intranet to the internet. Right? So here the scalability is defined as a system is capable of doing the significant increases in the terms of the numbers as well as also in terms of the resources as well as also the users. Even if the number of resources are increased or the number of users are increased, the system is continued to work. Right? So this is a simple example. See this, the growth of the internet from 1993 to the 2005. Now it says, the table it says the growth of the internet, the number of computers on 1993 and the number of web servers. See, in 1993 we have 130 web servers only, but on the 2005 these many number of web servers. See the tremendous growth. And looking on the other part, the percentage is flattened. The percentage is flattened. This flattening of this percentage, it makes the interesting point that more number of mobile devices and are simply wireless devices, and ubiquitous devices are become associated with the internet. Right. So based on this observation and the percentage observation, the significant growth in both the computers and web servers in this period. Yes, obviously, because as the demand for a resource grows, it should be possible to extend the system at a reasonable cost to meet it. That's why we need to increase the more number of servers and more number of computers. To make it very clear, for example, the frequency with which files are accessed in an intranet is likely to grow as the number of users as well as also the number of computers. So we have to add possible number of servers as a resources to avoid the performance bottleneck. Right? In general, for a system with n users, then it's supposed to support the quantity of the physical resources which are in order of n, that is proportional to the number of users. Right? And second thing, by considering the management of a set of data whose size is proportional to the number of users or resources in the system. So every algorithm is based on the hierarchy structure to deals about the performance bottlenecks. Not only on the hardware part, also the algorithmic part also we need to strengthen. It's supposed to be also to have the equal responsibility in scalable in nature. So the time taken to access hierarchically the structured data is order of log n, where n is called as a set of data. Right? So this trend, it indicates that the fixed and mobile growth in the mobile personal computing. So these all are the various distinct challenges of the scalable distributed systems. One is the controlling the cost of physical resources. Yes, that's why he said it's supposed to be order of n. It depends upon the number of users. And next, controlling the performance loss. That's why everyone is looking at the hierarchy structured data. Right? And preventing software resources running out. Right? So in this case, take an example of preventing software resources running out. In this case, let me take an example of IPv4 address. Now IPv4 address is saturated because the tremendous growth in the internet. The more number of devices are associated. So every devices are to be identified by using the addresses. So the IPv6 addresses are saturated. Now this belongs to the 32-bit address. Now in this case, now what we are trying to use is we are trying to use a IPv6 address which are 128-bit. Right? This is a universal truth. But to be fair to the early designers of the internet, there is no correct solution for this problem actually. Since the reason behind it is, it is very difficult to predict the demand that will come on year on year. It will come on year. Right? And another one thing, avoiding performance bottlenecks. So, whichever the algorithm, if I am going to define to succeed this distributed applications, that also supposed to be decentralized. To avoid the performance bottlenecks. So we have to use the decentralized approaches or the decentralized algorithms to handle this. So these are the way we can handle the scalable issues. Next, the failure handling. So as we know, the computer systems are sometimes fail. The fault may occur on the hardware part as well as also the software part. By giving the improper result or continuing to execution, it stops at the particular point. So here the failures are defined as the failure in the distributed systems are partial because there are wide varieties of applications. They are working on the concurrent nature. If there is any failure in the particular component, that is only for the partial. That component alone is failed. Because of this, the handling of the failures is difficult. So I have to use certain strategies to handle these failures. One is called as I need to detect the failure. First, we need to detect the failure. That is called as a detecting of failure. This case, we can say some failures can be detected and some failures really it is impossible to detect. Say for an example, when we are transmitting the messages, we have the concept error detection and correction schemes are there. CRC, checksum will play the role here. Definitely it gives a helping hand to us to detect some errors, detect some failures. Whereas the remotely available machine server is crashed on the internet side. Definitely this is a very challenging to find out this failure. Sometimes this cannot be detected but may be suspected. One of the way of detecting the failures as masking the failure. One of the techniques to overcome the failures is a masking the failure. Whichever the failures are detected, that can be hidden or to make the severity as less. So there are the two examples of hiding the failures here. One, the message can be retransmitted when they failed to arrive. And second one, the file data can be returned to a pair of disks so that if there is any one disk is failed, we can make use of the other one. Mirroring or a redundancy. This can be achieved with the help of the redundancy. Right? The other way is just dropping a message that is corrupted. As I said, the example is when we are working on the internet, if the web browser is unable to get the result, if sometimes it may fail, so it is generating the error code. Like say for an example, the 404 error. So what it will do, we are not trying to solve the particular error, just we are asking the user to retry sometimes later. Right? This is also example of masking failures. And next is the tolerating failures. So most of the services in the internet do exhibit failures because it is not so practical to attempt those failures and correct the particular failures. That's why we are tolerating that. Right? And recovery from failure. When I have to recover, we have to properly, strategically, we have to use this and from the design of software itself, from the design part itself. Right? So, recovery can be done with the help of rollback or backing up by using the backup concept or rolled back. Right? Next is redundancy. The next way to handle the error, that is called as a redundancy. To put more number of resources to tolerate the failure. The more number of same resources to tolerate the failure. So I have to use the redundant resources to achieve this. So that it continue to allow it to execute. Right? There should always be at least two different routes between any two routers in the internet. If there is any one route fail, we can make use of other route for transmitting the data. So in the DNS system, this DNS table, this lookup table is replicated at least two different servers. And the database is also to be replicated, so that failure in one pair, it should not affect the respective operation. Automatically the client will pass the things into the second server. Whenever any failure, automatically the second server will come into the place and it handles the request. And availability of the resources. Right? So the availability of the resources are measured in terms of the proportion of a time that is available for use. Based on that, the availability is defined. Right? Next important thing is concurrency. Both the services and applications provide resources that can be shared by the clients in a distributed system. There is a possibility that several clients will attempt to access the shared resources at the same time. Even if we are accessing on the same time, we are supposed to give the unique result to the every individual user. If we are not having the concurrency, automatically it limits the throughput. So what we want to do to have the concurrency or to increase the throughput, whatever the services and whatever the applications we have provided is supposed to allow to the multiple clients that can be run, accessed concurrently, or that can be processed concurrently. So to make this more concrete, suppose that each resource is encapsulated as an object, and the invocations and the invoking of that particular object are executed in concurrent threads. So in this case, there are several threads are executing concurrently within the particular object. So in this case, their operations on the object may conflict with one another, which leads to the inconsistency of the result. So the moral is, So what I want to do? So the moral is, any object that represents a shared resource in a distributed system must be responsible for ensuring that it operates correctly even in a concurrent environment. This is not only for the server, whatever the objects, whatever the components which are resided on the applications also. For an object to be safe in a concurrent environment, all the operations must be synchronized. Then only we can say that the data remains consistent. So this can be done with the help of the standard technique which most operating systems are using nowadays, that is called as a semaphore. The next is transparency. Right? So the transparency is defined as the concealment from the user and the application programmer of the separation of components in a distributed system. The system is perceived, the transparency meaning is the system is perceived as a whole rather than the individual components. This is a major influence on the design of the system software. This transparency gives a major influence on the design of the system software. Actually, generally we have identified the 8 forms of the transparency. We have identified the 8 forms of the transparency based on the standards, based on the reference manual of ANSA and based on the ISO standard reference manual of Open Distributed Processing. That are one is the access transparency. The meaning of the access transparency is called as which enables whatever may be the type of the resources to be accessed in the identical way. It may be a local resources or remote resources. And next is location transparency. Now this location transparency, it enables the users to access the resources wherever it is. Right? And third one, concurrency transparency. So every processes are allowed to execute the resources concurrently. Replication transparency, which enables the multiple instances of the same resources to increase the performances of the system. Failure transparency. Mobility transparency. Actually, we have paraphrased the mobility transparency, actually the term which is called as, the earlier term which is called as migration transparency. Right? Now we are stating that it's a mobility transparency, which allows the movement of the resources as well as also the client. The movement of all these things, it should not affect the operations. Right? And next is a performance transparency. Then scalability transparency. Right? So these all are the 8 standard transparencies, 8 forms of standard transparency. Right? So the 2 most important transparencies are access and location transparency. Now this we can say that these 2 are called as a network transparency. These 2 are called as a network transparency. Out of the 8, the 2 most important transparencies are access and location transparencies. Right? Now these 2 are referred to as a network transparency. Not but not least, the last design issues that is called as the quality of service. So I don't want to take much of the time in this. As what we seen from all these slides, almost 40 to 50 slides we have came across. All the 40 to 50 slides, some of the services are given to the users. The services are not a sum of the services. The services are given to the users. Now automatically, as the system's perspectives or as the administrator perspectives, one thing will immediately come into our mind. What is the quality of services for the particular service? What is the quality of the particular service? Right? So there are some of the non-functional properties will also leads to affect the quality of services that are called as a reliability, security, and the performance. Right? So what we want to do is adaptability to meet the changing system configurations and the resource availability has been recognized as a further important aspect of service quality. Whenever if there is any changes, we have to adapt with those changes. The reliability and security issues are the critical in the design of the most computer systems. Because here we are providing the services. So obviously we should know what is the quality of each and every services, which are in the part of reliability as well as also the security. Right? I hope you are clear about what are the various design issues when we want to develop any distributed applications or when you want to have a distributed system. Right? Thank you for your patience listening. With this, I will stop my presentation. If you have any queries, kindly ask your doubts at any point of time. Thank you.